Okay, let's forge ahead here. We sort of ran out of time on the last one, so this is V number 39. Still talking about assignment number 21. I'm doing problems 4 and 5. As I said before, I'll assign the same thing tomorrow. So here we have a cone, and again, the volume is given not in terms of pi, but 900 cubic centimeters. The radius is 3.5 centimeters, and you're required to find h. So this is the kind of stuff you'll get on your upcoming test. This is, what they want, either algebraically, which we were doing before, or using a calculator. And as I mentioned in the previous video, we're always rounding to 100th. I might change that a little later. You have to keep an eye on that. Sometimes they ask you to round to a tenth, and sometimes they ask you to round to a unit. So you got to keep an eye on that. You don't want to, especially if it's an open-ended question, you don't want to lose a point or two because of that. All right, so let's see. We need to find h, and we're given this data here. So let's see what we have. We have v equals 1/3 pi, and we have 3.5 squared h, and we replace v by 900. Now again, I've mentioned this again and again, there are different ways to do this. I always have algebra in the back of my mind, I have to confess. So I'm going to multiply this by 3 and come up with 2700 equals pi 3.5 squared h. And of course the variable is h here, I'm solving for that. So debatable, I don't know. You'll decide what's best for you. I divide by pi, and I divide by 3.5 squared on both sides, and I have pi 3.5 squared, again, on both sides. So when I cancel everything, as I must do, I'll work right to left this time. I have a little space here. I end up with h, can you see that? Yeah, barely, equals 2700 divided by pi times 3.5 squared. So now I'll move the board over here, and now it's simply a calculator problem. Don't be confused. There's no reason to use the squaring button, square root button I mean to say, because height is linear. And I mentioned in the previous video, kids get confused about that quite a bit. You should de-confuse yourself on that. Turns out to be very important. So here we go. I'm going to divide 2700 by pi times 3.5 squared. And as in the previous problem, I'll have to put this in parentheses in the calculator if I'm going to do it this way. Otherwise, the calculator, following order of operations, will divide 2700 by pi, but then multiply by 3.5 squared. So watch that. It comes up. All right, so here we go. Entering in the calculator, I turn it on, I clear it out, and I have, whoops, I don't want to use it, I don't want to block anything. 2700 divided parentheses, the pi button, times 2. Oops, oh my God, I got to go back one, back 2, made a mistake there, 3.5. Square button works, you don't need that with order of operations. And now I have to close that off. And so when I press my button, the enter button, I end up with 70.158 to 1,000. Double checking that that's what we came up with, that's correct. Circle the 8, round the 5, and the height in this case is 70.16 linear. Again, I have to stress that. That's part of the Common Core math, by the way. Linear centimeters. All right? So that's how you do number 4. And now we change topics with number 5. This is what we talked about yesterday in our videos. This all-important topic, subject of radicals and how they work, a new set of numbers for kids going into high school. Really, this is preparatory for high school more than anything else, trying to give you the basics that will help you succeed in high school. That's the goal of what I'm doing. And I'm asked to simplify radical 32, then I'm asked to simplify radical 45, and then I'm asked to simplify radical 80. So I'm going to do these, and again, I'm going to do it the wrong way first, and then I'll do it the right way. So here, we're talking about dual multiples or dual factors of these numbers, which happen to be composite. So if this were 31, we stop immediately. Reason, the number's prime. 32, okay, I can do that one. So I look for the biggest perfect square that works, and here's a common mistake. The kid says, oh, okay, I got this down now. 4 times 8. And 4 is a perfect square, and I'm done. But no, the simplification doesn't say that. It doesn't say you pick any perfect square. It says you pick the biggest perfect square that works as a dual factor. Think about what I just said. 4 is not the biggest perfect square that divides into 32. It's not the biggest perfect square factor. And you'll have to work on that for a while. Kids do confuse. 16 is the candidate for the job. Okay? So the correct answer would be 16 times 2, which again, as we talked about yesterday, and then easily you come up with the answer. The correct answer, simplifying this, is 4 radical 2. And now we turn our attention to 45. That might be a little easier for most kids. Think about that. If I write 3 times 15, that means you're not listening to me. 3 and 15 aren't perfect squares. I told you at the beginning of the year, at the very latest when we were doing Pythagoras, excuse me with this, that perfect squares are super important in Regents math. Super, super duper important. You have to know them, especially the easy ones. So this doesn't work. It's silly to write something like this. The perfect square that works, and many of you probably see that, is 9 times 5. So we continue. Radical 9 times radical 5. This step, of course, becomes mental math. And then the correct answer turns out to be 3 radical 5. All right? And I'm going to give you addition and subtraction problems where you can work on these things. That will be included in today's homework or assignment, I guess that's the proper word we use. Now, here we go with 80. And I'm going to make a mistake here. And you guys are going to tell me why. Well, you can't tell me why. This is all virtual stuff. 4 times 20. Doesn't 4 times 20 equal 80? Well, it does. And isn't 4 a perfect square? It is. But this doesn't work. This is not the proper simplification of 80. What other number goes into 80? Oh my God. If you think about it, it's 16 times 5. So some kids memorize them. Some kids get used to them because you do them again and again. But whatever way you do it, you'll be asked to do these again and again. So this is 16 times 5. And of course, the proper answer is 4 radical 5. All right? So there were the first 3 I gave you. I'll do the last 3. And nobody wants to turn this into the exercises with big numbers and all that stuff. There's no purpose. You just need to understand the principles involved so you can do the problems that lie ahead of us. Okay, so the set of the last 3 were these numbers. And they're all composite numbers. And there's 60. We want to see if 60 works. And I recall to you, if you recall, there was a second category. There are composite numbers, but their factors are all prime. I bring to mind radical 15 or radical 21. I brought that up yesterday. You got to watch out. Not everybody can be simplified just because you're a composite number. So you see a lot of the work, all year long we've seen that we did in 2nd grade, turns out, in 6th grade, excuse me, turns out to be really important. So let's see what happens here. Let's see, 54 54. What numbers are going to work here with 54? Oh my God. It looks like 9 times 6. No, 9 times 6 is 54. So that looks good. Does anything bigger work? Well, 16 won't work. And anything that's less, 4 or whatever, won't work. So here we are. I'm skipping that intermediate step. I think most kids were paying attention, got it. And the answer turns out to be 3 radical 6. I go to the next guy, and I think right away, 12 times 8. Is there anybody else besides 12 times 8 that I can do? 16 does 16 work? Let's see, 16 times 80 is 8 times 5 is 16. So it turns out that 16 works, and this is what? 16 times 6. And you can put it on your calculator and get 96. And so that turns out to be 4 radical 6. Kind of interesting how these numbers work. We will add, subtract, divide, and multiply them so you can see that they're just regular numbers, and we'll get very confident with them. 60 seems like a pretty big number. Is there somebody bigger than 4? Because we know we have 4 times 15. Well, to think about it, I go back and forth in my mind. What comes after 4? 9. 9 doesn't work. What comes after 16? 16 doesn't work. What comes after 16? 25. 25 doesn't work. So clearly the correct answer is 4 times 15. And the simplification of this one is 2 radical 15. So I'm going to give you some problems where we add them and see what you can do. And I'll go over them tomorrow. And if need be, I'll give you a little lecture on that. Oh my God, we're up to 12 minutes already. So that finishes the work that I gave you yesterday. I'll be working this morning to assign you more problems. And later, I'll do the 2 problems proposed from the Common Core in one of those videos that I did yesterday. And I'll do both of those problems in detail. And if there's time today, maybe not today, but at the latest tomorrow, we'll start talking, as I mentioned in my letter, my missive to you guys this morning, that we'll be doing more work on prisms, surface area for both volume and surface area. So we got a bit more work to do before we're ready to take our test, which is being snipped out and put together as I speak now. Okay, good enough.